we ended the lecture by having that proof. We have proved that A, the acceleration for an object that moves in a uniform circular motion equal to v squared over r, where v is the velocity of the object in that motion. And that we call that the centripetal acceleration, and it's always directed from the center out. This is the acceleration for an object that moves in a uniform circular motion. A equal v squared over r. I will take two examples for that. Actually, do you remember last time we proved three statements, three equations that convert the motion from angular motion into linear motion. We said that S, linear displacement, equal to r theta. We also said that V, linear velocity, equal to omega r. We also said that the acceleration, linear acceleration, equal to alpha r. This is linear displacement equal r, the radius, times the angular displacement. Linear velocity equal the radius times the angular velocity. Linear acceleration equal to radius times angular acceleration. Knowing that equation, V equal to omega r, and knowing that A, the acceleration, equal to V squared over r, that means that A, I can replace V by its value. It's equal to omega square r squared over r. That means that the acceleration equal to omega squared r. And this is another form for the same equation, which is V squared over r. So if you know the linear velocity, you can still get the acceleration for an object that moves in a circle. And if you know the angular velocity, you can still get the same acceleration. Knowing this and applying this to real life, scientists has came to accelerate protons by putting them to move in a huge circle. Each time they move, they get accelerated, and they get accelerated, they get energy. And when they have a very high energy, they make them collide with different samples. Then they study the properties of those samples. And this is the biggest accelerator in the United States. That's the Fermilab, and that's in Chicago. And this is few kilometers. The radius of that, it's few kilometers.
Isn't there a bigger one in Europe?
This is the biggest one in the United States, yes. And again, going back to real life, when you go and get trained to fly in an aeroplane, they have to make sure that you can stand an acceleration equal to 9 times the gravity. They put you on an object that moves with an acceleration equals to 9 times to the gravity. If you can survive that, then you can become a pilot. And the reason for this, actually, it's mainly for the F-18 fighter. Mainly for that, the reason is when you go with that high acceleration, the blood will not reach to your brain and you will faint. Some people faint, some people don't. So they have to put the pilot who is going to fly on the F-18 on that test before they fly, to make sure that actually they will not faint on the airplane. So actually what they do is they put them in a simulator that moves in a circle with a velocity v in such a way that it will produce an acceleration equal to 9 times the acceleration of the gravity. Okay guys? So we'll put someone on here. We'll put one of you on that ID, my ID, and we'll make him rotate with a velocity equal to something that will give us an acceleration equals to 9 times of the gravity, acceleration due to gravity. Now I'm asking you guys to calculate that radius. That radius. What should be that radius if we know that that object moves with a speed equal to 300 meters per second? Did you get the problem? Should I say it again? Farida? Okay. How about you solve in a piece of paper and you can discuss it with your colleagues and let's get an answer together. Sharif, are you solving? You done it? You have done it? Good morning. That pilot is going to rotate in a circle with a speed equal to 300 meters per second. And we need the acceleration of that object that moves in a circle to be 9 times the acceleration of gravity. What is the radius of that curve? Of that circle that the pilot will rotate in? It doesn't matter if you get the radius, then you got the diameter. Here he's asking about the diameter. What are we going to do? What information do we have? Yahya, what information do we have? The speed v, which is equal to 300 meters per second. What else? The acceleration, which is equal to 9g and we know the relation between v and a, we know it. And all what I want from you guys is to calculate r. This is a very straightforward problem. R or the radius or the diameter. So do you have an answer?
The radius will be 10, the diameter will be not 10, it will be 1,000 and the diameter will be 2,000.
Okay, so the diameter is 2,000.
2,040.
The diameter is 2,040? That's the... What was your G? 9.8. What was your G?
9.8.
But isn't that out?
Maybe. Yeah, we'll see. We'll see. Well, that's close enough. That's close enough.
That's just the approximate, not
Yeah.
the exact.
Yeah. Okay. Yeah. Thank you. So I forgot your name again. Yasmin, you got the exact answer, and Nada? Nada got an approximation. She approximated it to get the answer. So both of you are correct. Yeah, because Nada said that actually I asked for the approximate answer, approximate diameter. So both are correct. So let's look at the answer. A. Yes. You get the radius and you multiply by 2, you get the diameter. A equal to V squared over R, and we know that A has to equal to 9G. Then plug in the values, we can easily calculate R, and R is going to be approximately 1,000 meters, and that means that the diameter is 2,000 meters. That was very easy. That was a very easy problem. Okay, another one. A propeller on a stunt plane spins with a frequency, so this propeller spins with a frequency equal to 3,500 RPM. Yes. What's the RPM? Boys, you know that because they drive cars. They are interested in cars. It's rotation per minute or revolution per minute. Same thing. It's rotation per minute. So that thing rotates 3,500 rotation in 1 minute. the length of each propeller blade is 80 centimeters. So that length is 80 centimeters. What the centripetal acceleration does at a point at the tip of the propeller. So we need to find if you have a point in here, what will be the acceleration of that point? So what to do? Nada is saying, well, we have to find the velocity, and knowing R, we can calculate the acceleration. That's what Nada said. Think about it. Think about it. Look at the units. This is what I want you to think about, that number. 3,500 rotation per minute. Mm-hmm. Okay. I forgot your name. Amira? Amira is saying, well, each rotation, the object moves 2 by r, a distance of 2 by r. So if I know r, I can convert that into, instead of rotation per minute, into meters per minute. And that's velocity. If the object moves in a circle, starts from a point, then goes in a circle, okay? It starts from that point and goes around and ends up at that point. What is the distance covered by that motion? Distance. 2 by r. 2 by r. So each rotation represents a distance equals to 2 by r. That means that the 3,500 rotation represent a distance equals to that number times 2 by r. And this will give us the velocity. Per minute. It's going to give us, who asked that? Who talked about S? Yes, it's going to give us the distance per minute.
Can't we just use the rate of change of the angle? Omega.
Do you know it?
Over time.
Mhm.
So we know that 3,500 is RPM.
Mhm.
1 round is 2 pi, so you multiply.
Yes, same thing. Yeah. Actually, that's a good answer. Sharif, look. 1 rotation per minute, that's nada. 1 rotation per minute, 1 rotation per minute. I want to convert that into seconds, so I'm going to convert the minute into seconds. So I will multiply that one here by 60. And we'll multiply that by 2 by radians per rotation. Each rotation has an angle equal to 2 by radians. That angle, that's 2 by in radians. So now I have converted that unit, that 1 rotation per minute, into radians per second. Okay, guys? Again, 1 rotation per minute. One RPM. We need to convert that into 1 rotation per second. What to do? Hey, what to do? What was the question? Convert what?
The original question, or are you asking me now?
What I'm asking you now.
Convert it to seconds.
Convert what to seconds? And what is that? Okay, can you convert one rotation per minute into, not into seconds, as you said, into rotation per second?
That's
So what to do?
Divide by 60.
Divide by 60. So to convert that into RPS, which is the rotation per second, then 1 over 60. Right? So that means that the 3,500 RPM equal to 3,500 over 60 RPS, rotation per second. Good. Wait. I did not finish. Now, we need to convert that rotation into radians. Each rotation has an angle equal to how many radians? How many degrees? 360. And 360 equal to how many radians? 2 pi. Okay? So I'm going to, that should equal to 3,500 divided by 60 times 2 pi. And now the unit is radians per second. Did you understand it now? This is what I just did on the board.
The unit of centrifugal velocity.
Radians per second. Meter per second. What is the unit? What units of that? Units of what? Velocity, linear velocity.
Yeah.
Okay? Angle per second. Radians per second. What kind of velocity is that? Angular velocity. Right?
Meters per second is can also be centrifugal velocity. Meters per second is what units per second. There's no such thing as
Yeah. There is no such a thing that's called centripetal velocity. Yes. Okay. Okay, Nagy, can you move in here?
Can we solve using linear velocity?
Excuse me?
Can we solve this using linear velocity?
Oh, yes, sure. So what we got now is the angular velocity. The angular velocity will equal to, Nagy, angular velocity equals to, what? We got the angular velocity, right? And what is the value of that angular velocity? That's 3,500 divided by 60 times 2 pi. And wait, and this is radians per second. Okay, and that's omega. And we need to calculate the acceleration. Acceleration equals to, Ali, do you know what, can you give us a formula for the acceleration? Omega squared R. We know omega, and we know R, we can get the acceleration, that's easy. Okay, and someone said, can we calculate it using the linear velocity? Who said that? Yeah, sure. Do we have a relation between V and omega?
Yeah. V equals
Omega R, that's going to be in the formula sheet, so do not worry about it. So V will equal to omega times R. Then if we know V, can you find the acceleration? Okay, so you get the same answer. Are you following? Because you phase out. I don't know why do you phase out. Farida.
omega, the units or radians per second.
Yes.
Okay, so if it's radians per second and you're counting it by R.
Radians, if you look at it from the very technical point of view, radians is actually not unit. Angle, the angle does not have any unit, just an angle. So radians per second, if you multiply it by a meter, you get meter per second.
You mean that the radians is
So the unit here is meter per second. Okay? That one? That was the last lecture. So please come to my office after that because it's going to take a long time to do it again. So you come to my office, I will explain to you. Anyone who wants to prove that again, come to my office, I will prove it to you again. Yes.
Omega equals theta over t.
Yes, omega equal to the change of theta with respect to t, as v equal to dx over dt.
They change in
So, look at that object. Were you here last time?
no. Yeah.
Okay, Nagy. Does it move? Does theta change? Assume this is theta equal to 0. Does theta change?
Yeah.
Yes. So this is why omega is d theta by dt. Okay? What else? Ali? Okay. So that's it for chapter 4. One more thing before we go to chapter 4. Do you remember? I told you guys forget that moon thing. And that one, too. Oh, okay. I think I'll get in chapter 5. Stop recording. Henny.